Namaste everyone, my name is Srikanth Rangdal. Welcome to my channel CADiMate, where we give life to the boring subjects using CAD technologies. In today's video, we'll be solving a complete question paper of JNTU, which appeared for CSE and IT, and you can see the regulation is R16, and it appeared in the November-December 2020. Every year, actually, I solve the JNTU question papers so that the key for the JNTU could be provided to the invigilators, to the people who are actually making corrections. And this is one such instance, and while I was solving, I thought, why not record the same video and make it available for my subscribers. So without making much ado, let us start. So the first problem is a very common problem, and it has been solved so many times, and it has appeared in so many question papers. So instead of just solving it and repeating whatever procedure we have already seen in the other videos, I thought it will be best for me to copy paste it here. But of course, I would like to solve and show you what is unique about this particular problem which appeared this year. This year he has slightly twisted the question over here in this particular sentence. He is asking us to draw tangent and normal at a point which is located 45 mm from the second vertex, not from the first vertex, from the second vertex. So first vertex is this vertex which we all know about. So this distance 45 mm which he is talking about, it's not supposed to be measured from the first vertex. It's actually supposed to be measured from the second vertex. So I'll have to delete these tangents and normals which we had drawn last time. Now I have seen various different methods to mark a point on the ellipse, and then of course the procedure to draw tangent and normal is the same. But this particular way of asking the question, this is something I'm watching it for the first time. So let us see how to solve it. So we have been told that it is 45 mm from the second vertex. First we need to find the second vertex, which is this point here. So I'll just do one thing. I will take this point over here, place it here. I'll just name this as the vertex, and this is the second vertex. This will just remove it. So this point here is the second vertex. Now from the second vertex I need to take a distance of 45 mm. So I'll take a circle and 45 mm. Now those who are doing this with manual drafting, you will have to take your compass, measure a distance of 45 mm, and keeping the pointed node over here with pencil, you have to make a mark here on the ellipse. Now we can draw the tangent and normal above or below. It's our choice. So let's go ahead and draw it above. So I'll just mark a point at the intersection of the two curves, and that's it. That's the work. The work of this circle is over, so I'm just deleting it. Now at this point I need a tangent and a normal. So for that to do, what I have to do is I have to join this point straight away with a focus point, and then I'll have to draw a perpendicular to this. Now I'll have to take a draft to keep it exactly at this point, parallel to this, and using the other edge I'll have to draw this line. So this line here is perpendicular to the line which we have just drawn. The intersection of the directrix and this line is what gives us one end of the tangent. So taking this point intersection and joining it over here with point P, we get the tangent. And once the tangent is drawn, once again we'll have to take the drafter, keep it over here, and draw this other edge to get the normal. So that's it. We have drawn the tangent and normal to this ellipse from the second vertex point at a distance of 45 mm. So this solves the first problem. Now let's go ahead and check out the second problem. This time it seems that the examiner has thought a little about presenting the questions, because the questions you can see they have been localized. So he's telling the distance between Hyderabad and Chennai is around 600 kilometers, and its equivalent distance on the map, it measures 30 centimeters. So we have to draw a diagonal scale which indicates 223 kilometers and 135 kilometers on that. Now there is a slight twist in this question paper. He's even though telling us that 600 kilometers are measuring 30 centimeters, you're not actually supposed to draw 30 centimeters on the drawing sheet, because 30 centimeters, you can see it's a very big number when you're especially considering a small drawing sheet provided for the JNTU examinations. So what do we have to do? We have to find out what is the maximum length that would allow us to mark these distances on it. So we are asked to measure 223 and 135 kilometers. So maximum distance that we have to show on our scale will be near about 300 kilometers. That should be enough. And if 600 kilometers measures 30 centimeters, 300 kilometers would definitely go for 15. You must have observed here one more thing, that I am not actually finding the RF value, because RF value is not being asked in the question. I could just use the mango type problem to solve this straight away. So let's begin. So once again we'll have to take our drafter and keep it in such a position that it's exactly horizontal. Then using this drafter we'll have to draw a horizontal length of 15 centimeters. Now even though this length is 15 centimeters, actually it represents 300 kilometers. So now we need to divide this into a number of parts. How many number of parts? Well, this is 300 kilometers, so let's make 3 equal divisions to get 100 kilometer each. So once again we can bring back our drafter, and you can see 15 centimeters can easily be divided into 3 parts. So each part will measure 5 centimeters. So a point here and a point here. That should be enough. So now we have a 15 centimeter line divided into 3 equal parts. Now we have been asked to create a diagonal scale. Now diagonal scale, the thickness of diagonal scale will be 5 centimeters if you are making 10 smaller subdivisions, or it will be 12 divisions if you are making a conversion of feet into inches. So in this case, of course, we need 10 smaller divisions, so the height of this scale we are supposed to take as 50. So after having taken this, we'll have to draw a vertical line here. Of course, all these you can do it with the drafter, those who are doing manual drafting, and those who are using AutoCAD, of course, this line command is straight away available with you. Please ensure that the object snap setting is on, and in the settings perpendicular and all other such options are active. Okay, let's go ahead to the subdivisions of the scale. Now each of these divisions are measuring 5 centimeters, and we are supposed to divide this first division into 10 subdivisions. Now 5 centimeter can easily be divided into 10 parts, and each of these parts we are going to be getting it as 5 mm. So once again you can just go ahead and take up your drafter and easily make these 10 divisions. So I'll just take points at these divisions. So 0.5 gap. So all these subdivisions are going to be appearing at the distance of 0.5. So you can just go ahead and make all these subdivisions. So we now have the 10 subdivisions within the first division. We can take away the drafter. Now we'll have to draw the diagonals. Now to draw the diagonals, what we have to do is join this first point here with the top left corner. Now this line is not a vertical line, it is slightly slant, and that slant is what going to allow us to make subdivisions. Fine. So we have already made 10 equal divisions within 100 kilometers. 10 equal divisions within 100 kilometer means each of these smaller divisions measures 10 kilometers. Now these 10 kilometers are further supposed to be divided into 10 more parts to get 1 kilometer each, and that's what is going to allow us to mark these given dimensions, 223 kilometers and 135 kilometers. So let us go ahead and complete this scale. So now what I have to do is I have to copy this diagonals and then paste it, pick it from this bottom point, and go on placing it at each of these points. Now what do the manual drafting people can do? So they just need to place their drafter in this particular position, and then they need to just move it to the next point. They need to move this point drafter to the next point, and they need to draw this line over here. So this they need to continue doing for the entire length till all the points are covered. Now we just need to divide this vertical length into 10 equal parts. How do we do that? We have already taken this length exactly as 5 centimeters. So 5 mm gap, if you take offsets, we'll naturally get this. So I'm using command of offset with AutoCAD. Those who are using manual drafting, of course, they can make use of the drafter and go ahead take drawing horizontal lines at a gap of 5 mm. So now our scale is ready. It just needs to be decorated a little. So this distance here is 0 kilometers, this one here is 100 kilometers, and here we have 200 kilometers. So where is one extra kilometer? It is here on the back side. Now this extra 100 kilometers has been subdivided into 10 parts, which means each of these small parts is 10 kilometers, and each of these 10 kilometers further has been divided into 10 equal parts using the diagonals, which means each of these step going up actually measures 1 kilometer exactly. So what if you want to measure a distance of 223? So we have to take it in divisions of 200, 20 and 3. So how to get 200 divisions? It's very easy. From this point here to the line, to this line, the distance between these two vertical lines is exactly 200 kilometers. Now going back by 2 subdivisions, we are going to get the distance between this point here and this line over here is 220 kilometers. Now 3 kilometers we have to take. So for getting 3 kilometers we have to climb up on this diagonal scale by 3 divisions. So 1, 2 and 3. So the intersection between this third line and this diagonal over here, that intersection to this line, that's what gives us exactly 223 kilometers on this diagonal scale. So there it is. You can see I have marked the distance and it is measuring 223 kilometers. Now let's go on to measure the other distance that is asked from us, 135 kilometers. So this again we need to divide into 3 parts. First part is 100 kilometers, and that is the distance between this line and this line. Then we got to take 30 extra kilometers. To get 30 kilometers we'll have to go back by 3 subdivisions. So the distance between this point and this line is 130 kilometers. Then we need 5 extra kilometers, for which we'll have to climb up on this line to this 5th line. So the intersection between this line and this line, that distance exactly measures 135. So that's it. This second problem has been solved. Now let's next go for this question, the third question. Now this is a question on projection of lines. Now here what is given? The given data is a line AB of 90 mm length. That means 90 mm is its true length. Its end P, which is the first. Oh, wow, there has been a typing mistake here in this question. Even though the question starts with the line AB of length 90 mm, then it's proceeding to call the first point as P and the second point as Q. So actually I think the correction here required is PQ is the line 90 mm long, its end P is 15 mm from both HP and VP. The other end Q is 50 mm above HP and 60 mm in front of VP. So we have to draw the projections of the line and determine the inclinations of the line with HP and VP. So let us just assume that the first point P is also in the first quadrant, and when the point P is in first quadrant, let's see how to get its projection. First, of course, we need to draw the XY line. So I need a horizontal line. Those who are doing manual drafting, of course, they can place their drafter horizontal and easily get this line. And those who are using AutoCAD, you can either keep your polar setting on, or with ortho setting you will easily get the horizontal line just with line. Now I have to mark the projections of the end P. To do that, I'll have to first go to the OSNAP options. Go to the OSNAP settings, mark this nearest point as on, because we're going to need some point on this line. from where we need to make measurements. Now you can see, because the ortho is on, I'm getting it vertical line. So the point P is 15 mm above. So 15 mm above, the point that we get, I'll just call it as the front view, which is P dash. Then from XY line, we'll have to take below. The top view is going to be 15 mm once again, and that point is going to be P. You must be remembering here that front views are all named with dashes and top views are named without dashes. This makes it easier for us to identify which one is front view and which one is top, especially when both of these are getting mingled into each other. So that happens, of course, when the point is in second quadrant or the fourth quadrant. In first and third, of course, they remain on the opposite sides of the XY line. Now we have started by feeding two of the given conditions, the distance of P from both from the HP and VP. Now let us proceed to see what other data we can feed into it directly. The true length of 90 mm we need to feed it, but true length is never going to be parallel to XY line, so we can just skip it for a while. Let us see what other data is given. So here we've been told that the other point Q is 50 mm above HP. So we got to take a line which is parallel to this. It needs to be horizontal and it needs to be 50 mm from it. So I'll go ahead and take offset command, and distance is 50 mm. At that distance we have to take it above the line. Now the second point is somewhere going to be on this line. Where exactly, we don't know, but we know that its true length is 90 mm. So that data can be used especially very efficiently by us. So we need to take circle. We're keeping this point at keeping the center at this point. We have to draw a length of 90 mm. So you can see there is a circle here which is having a radius of 90 mm. Its center point is here and it is intersecting here with this line. So this line that I draw here up to the intersection point, it's exactly going to measure 90 mm. So that's the first step we have to do. Next, the data that is given next is it is 60 mm in front of VP. So in front distance, it's going to be of course visible in the top view. So the top view of course is going to be below XY line. So let's take an offset of 60 mm parallel to this line below. So you can see this line has been placed over here. So once again, making use of the true length, which is 90 mm, we can draw a circle of radius 90 mm which will intersect with this line at 60 mm from the XY line. So the intersection of that point will give us a true length once again. So because the work of this circle is over, I'll just erase it. Once again, let us see what is the length of this line. Yes, of course, it is 90. So both these lengths are true lengths. Now what is the end of this true length called? The name that is supposed to be given to this end is Q dash, but this is not the final point. This is just a temporary point, and hence we need to call it Q1 dash. And same way, this point is different point compared to this, so they are not the same points. So I need to call this as Q2, not a dash, remember, because this is a top view, we should not be taking any dashes. So next we have to take point starting here up to the horizontal here. So that's where we get the front view of the point Q2. So the front view, of course, we have to call it as Q dash. So Q2 dash is the front view of Q2. Same way, we will have to take projection of this point. Of course, nearest point is disturbing me once again, so I have to go back to settings, turn off the nearest option. So now when I take a line, automatically it jumps to the end point. So this point I have to take up to the horizontal here. So this point here is Q2 dash, and this point here, it is Q1, the top view of Q1 dash. So now that we have drawn the lines such that they are inclined only to HP and only to VP, we have to get a position wherein the line will be inclined to both HP as well as VP. And to do that, we will be using a circle once again. Actually, we are supposed to use an arc, but since an arc option is difficult to make here in AutoCAD, especially in this scenario, I'm just going to draw a full circle, and then I'm going to trim off the side which is not needed. So this is the part that I'm going to require. So this point here is the final point Q dash, and this here is the final front view. So repeating the same thing for the top view, we are going to get the final top view over here. Oops, this is the point. Yep, it's this intersection here that's important. Let me just move this away so that it doesn't disturb it. Once again, this line here, this is the final top view. Now we need to just again trim off this complete circle because we won't be requiring the full circle. Now of course we just need to make some small changes to make it look good. We can reduce this length over here using stretch command in AutoCAD. Of course, those who are using drafters, they have the independence of drawing as much big a line as they want. So this problem has been solved. That there is a last teeny tiny step that we need to do. He's asking us to draw the projections of the line, of course, and he's asking us to determine the inclinations of the line with HP and VP. So what is the inclination of the line with HP and VP? So let us see. Let's take this angle, measure this one here. So you can see it's 23 over here and 30 degrees over here. So what you can do here is you can write the answer separately over here. So the answer, inclination with HP is 23 degrees and the inclination with VP is 30 degrees. So that's it. That is the solution to the third question. So it's just been around 22 minutes and we have already solved the third question. There are only 2 questions remaining for us to solve. Oops, sorry, there are actually 3 more questions to solve. So wait, let us go ahead. Wow, the next question also appears to be slightly surprising. Seems the examiner was very creative whoever made this paper. I'd like to congratulate him on his creativity, because he has, I think, tried to cross the borders of the textbooks and tried to invent new kind of problems which will continue to surprise the students in the examination hall. But of course, the students who know the basics will definitely be able to do it without any problem. Let us see what the question is. So we have to draw the top and front views of a rectangular pyramid of sides of base 40 mm into 50 mm. You can see this is the twist given to here, the problem here. So generally what the students draw are the right regular kind of pyramids. So pyramids whose bases are regular polygons, but this one is a rectangular pyramid, which means the base is not exactly a square, it's a rectangle. One edge is 50 mm, the other edge is 40 mm, and it has a height of 70 mm. Now when it lies on one of its larger triangular faces on HP, the longer edge of the base of the triangular face lying on the HP, that is inclined at 60 degrees to VP, and the top view of the apex of the pyramid being near to the VP. So let me just show you how this pyramid looks in 3 dimensions. So if you see it in top view, this is not exactly a circle. This edge over here is measuring 50 mm, whereas this horizontal one is measuring just 40 mm, which means it's a rectangular cross section at the bottom, and there is a single vertex at the top. So when you see this pyramid in isometric view, this is how it appears. You can see this is how it rotates. This triangle, the green triangle here, is the bigger triangle, whereas the red triangle that you see here is the smaller triangle. So when he's talking about the big and small triangles, this is what he means. The green one is bigger triangle, the red one is the smaller triangle. So let's keep this question aside and start solving it. First, of course, we need to draw the horizontal line, which is the XY line for us. Now we have to start with the top view. The top view has to be appearing in such a way the longer edge of the triangle has to be resting on HP. So for that to happen, we'll have to take the longer edge vertical. So I'll just take a rectangle, click the first point here. I will use the dimensions option inside the rectangle, and the horizontal length is 40, vertical length is 50, and then I'll just click on one of the four corners. Now you can see the top view of my pyramid is ready. So in the top view, the slant edges are also going to be visible, so I'll have to join the diagonals and these edges will also become visible. Next, I'll have to project the front view of this pyramid. So to do that, I'll have to take projection lines from here. This is the base, and then I'll have to draw the height. To draw the height, I will draw a projection line here, and I will take a height of 70 mm. So from the height, it needs to be joining these 2 points over here. So this here is the front view of this pyramid. Now what it says is the bigger triangle. That means this triangle over here, it is resting on HP. So I have to make a copy of this, and I have to rotate it such that this edge over here will become horizontal. So I'll take the rotate command. I'll have to use the reference point. This point I have to keep over here. So the second view of ours is ready. Now we need to make the projections of these, and we should complete its top view. Just break these points to intersection. Yeah, this is already broken. I will trim this off. So this here, these are the visible edges. Now there are going to be 2 edges which will not be visible. Those are going to appear over here. Is the problem over? Is the solution over? Let us go back to the question and try to see if it is over. We can see it is telling that the bigger triangle is resting on HP, and the question doesn't end over there. It is continuing. It is telling us that the longer edge of the base of the triangular face that is lying on HP, that base is inclined at 60 degrees to VP. So in this view here, you can see this edge is the edge which is talking about, and this edge right now it is perpendicular to VP. We have to make this edge at 60 degrees to VP. So right now it is 90 degrees, we have to make it 60 degrees. So how much do we have to rotate it? I'll have to first make a copy of this, and I'll have to rotate it by how much degrees? Just 30 degrees. So I'll just rotate it in, okay, let me make it anti-clockwise itself, 30 degrees. So this here is the final top view. This here is the final top view. Now using this final top view, we need to project it and create its final front view. These 2 points are to be above. We have to match it with these points, and these 2 points are going to be at the base. Now that we have got all the points, we have to join them using the outermost boundary, this one. The visible edge is going to be this one, because you can see the face here, this face here is facing the observer, so this edge is going to be visible, and this final edge will be hidden. This one will be hidden. So that's it. That solves the 4th question. Now I have not done the naming for all these problems. If you get time, of course, you know how to do the naming. You just copy paste the text from different points and double click on the text to name that. Okay, so the 5th problem once again surprises me slightly, because generally almost all the question papers, they go for either hexagonal prism, pentagonal prism, pyramids of some kind, cylinders or cones, but this guy over here went for a simpler problem. a triangular prism. So triangular prism is having the base of 30 mm and height 40 mm. So which means the base is of course a regular triangle, equilateral triangle of 30 mm sides, and the height of the prism is 40 mm. So it stands on HP on the base. That means it's resting on the triangular base on HP, and a rectangular face is perpendicular to VP. It is cut by a plane perpendicular to VP and inclined at 30 degrees to HP, and it has to pass through a point 20 mm of the base along the axis. Okay, let us see how to draw this. Of course, the starting point for all the projection problems is the XY line. So let us draw the XY line, and then we'll have to draw a triangle. So for triangle, I'll just take a polygon command with 3 edges. I'll use the edge method for drawing, and there goes my triangle. So the edges of the triangle need to be 30 mm long, so edge length I will feed 30. So this here is the top view of my prism. Next, I just have to draw the front view of the prism. The height of the prism has been given as 40 mm, so I'll just go ahead and draw this and complete its front view. So this here is the front view of the prism, this here is the top view. Now we might need to draw the axis of this prism as well. So if we have to first find the centroid of the base by joining the midpoint with the opposite corner, once again midpoint with the opposite corner. Once the centroid is got, from the centroid we need to draw the axis. Let me take the axis here. Now that we have got both the front view and the top view of the prism, we have to cut it. So the cut happens at 30 degrees to HP, and it passes through a point 20 mm above the base along the axis. That means we have to get a line. So I'm using a polar method to create a line at 30 degrees. You can of course use the polar setting over here at the bottom as well, but you must of course ensure that the multiples of angles is set to 30 degrees. Now I'll take a line command, and at 30 degrees I will just draw a random line. The midpoint of that I will first place at the axis, the bottom end of the axis. Then I'll just move it up by a distance of 20. So this is the easiest method to get the section. Now this section of course we'll have to cut it over here, so the top part actually goes away. I'm using break command over here to make these lines separately so that we can select them separately. So this is the part that we got. So the bottom part is what we have to develop. The bottom part is what we have to develop. So to draw the development of this, it's a prism, so we'll have to start at some point. Let us start with this point over here, or else it's better of course to start with the lower points. And okay, so let us start with that, but I think before we'll have to give it some names. So let me start with this point as A, this point as B, and finally this point as C. So I'll start with the point A. So I have to go with a line of equal length. Let me just reduce the size of this. I'll take this line. So this is going to be my first line, and then I have to take horizontal line. The length of these lines have to be equal to this. So those who are doing manual drafting, they need to take this measurement using the compass. With AutoCAD of course I can go on to take a circle, and because its radius is going to be same on all the sides, I'm going to use the radius as a measurement tool to mark these equal distances. Yeah, so this I've got the base triangle opened. So the first point I'm going to be taking it as A. The second point is going to be B, C, and back to A. So this is going to be B, this is C, and last point of course back to A. So okay, so first let me draw the full prism, development of the full prism. So this is the development of the full prism, and then I'll have to cut it. I'll have to draw a vertical line crossing from these 2 points. and then you see A point is getting cut over to this point, so these 2 points become important for us. And then the B edge is also getting cut at that same point, so B also is going to be at the same point, whereas C is getting cut at this point over here, so the C point is going to be here. So joining these will give us the development. So starting here, coming here, here and here, and I'll just break this line and this line. So this here is the development of this particular triangle. So we may also go on to give the same names over here, and the same names actually come in the development. So we have to ensure that when we are drawing the projections, the letters have to be smaller, and when we are doing the development, the letters have to be larger, because larger letters do not actually mean that they are projections. Smaller letters actually mean that they are actually projections. Larger letters usually mean that it is an object that we are trying to represent. So having done the 5th problem, there is one last problem for us to go for, and this one is a conversion problem. So this is the problem that we have to solve. So an isometric view of an object has been given to us. We have to draw the front view, top view of the figure. All dimensions have been given in mm. So we have not been told to actually draw the side view, but I think I'm having a feeling that we'll have to draw the side view in order to get the front view and top view correct. So that means here again the intelligence of the person who designed this question paper again surprises me. So let us go ahead and solve it. First, of course, we'll have to start with the XY line as usual. Now let us try to build its front view, or shall I say the side view, because of course the side view is going to be necessary, because tangential webs are found here, and we have to find where exactly the webs are going to stop. And in order for us to be able to find that properly in the top view, we of course need to draw the side view first. So let us see how to draw this. So I'll have to first draw, I'll just start with this center line over here, that's 25, and then there is a small gap here, that's 4. So let me take offset of 4 above here, and this length has got to be 85. I'll take a center line here, and this length here is 85. 85 means it's going to be 42.5 on both the sides, so I'll take offset 42.5 on both sides. So from center 42.5 this side, and from center 42.5 on this side. So the total length, if you see, it's going to be 85. So I'll just have to extend these lines, trim this off. Okay, so what's the height of this length here? That's 18. So offset of 18, I'm going to take it here. So this is where this edges are stopping. The bottom here, it's also going up. Where exactly? These edges are not required. So you can say my side view is actually taking shape. The side view actually is going to be much bigger than this. So I have to take this down a bit, move this aside. Okay, so this distance here is once again 85, the distance of center from this point here. So I'll have to again take an offset of 85 from this in the upper direction. Then I'll extend this line here, the axis line here. The intersection of this is what is going to give me the center point of the circle. Now I have to use this point and draw the circles. You can see one diameter is 45 and the other diameter is 30. So both the circles have been drawn. Now we have to draw tangent to the outer circle from this point over here. So of course you should not be joining the quadrant, you should be making it tangential here like this. Now if you're using the manual drafting, you'll have to be slightly careful. You'll have to draw the lines such that it's exact, it's almost touching the circle. You have to place this scale properly in order to be able to do that. Okay, so now that the side view is almost drawn, I have to hide one of the edges, which is not going to be visible from this side. It's this edge over here. Now one more thing I forgot to mention when I started drawing this is you should decide where to place the side view, so that the place, for the front view and top view are going to be decided in the first diagram itself. So you will have to draw this on the right side, because this is a left side view. It's going to be on the right side, and the space for front view is going to be left on the left side of this diagram. So this is the side view. Now we can start projecting this to get the other view, that's the front view. Let us start doing that. So okay, fine. So let's proceed. I'll have to take a line from here, then a line from here. So this gives us the starting, the top cylinder over here. I'll take the starting point somewhere, and I'll just break these projection lines, because this is where the solid lines are going to begin. The total length of this is 150. I think I'll have to extend this slightly more. Well, so especially the students, if they're using a drawing sheet and manual drafting, they'll have to plan ahead how much of space this diagram is going to take, so that you'll not end up going out of the drawing sheet. With AutoCAD, of course, I have the option of moving these objects around and placing them as I need them. With manual drafting, you don't quite have that option, so you got to be extra careful. So let us proceed to see what is the next thing we have to draw. So next thing is this one over here. Okay, so now comes the important part. So what is the distance of this plane here from the endpoint to the cylinder? Oh, wow, that I think has not been given to us. Yes, almost all the dimensions have been provided to us, except the distance of the end face of the cylinder, the distance between the end face of the cylinder and this face over here. That distance is forgot to mention, and we are not even sure whether these two lengths on both sides, they're equal or unequal. My guess is, because this object seems almost symmetrical in all respects, we are going to assume that it is symmetric on that level as well. So if you're going with that assumption, we'll have to take the midpoint of this cylindrical part, draw an axis line to the bottom, and whatever distance comes out here, we have to take half of that on both the sides. So because that length is 120, 60, it's going to be both sides. Okay, so that's how I'm going to proceed. Okay, fine. So this edge is going to break over here, and then you can see here 20 distances are there on both sides. So I'm going to take a distance of 20 mm from here and from here. This is not going to be visible, this is going to be whole, and of course, even though here you can see there is no edge given here properly, but there are two plane faces intersecting at this point, so this has got to be an edge. You can't just make it filleted. Even these edges, here the intersection has not been shown to be round exactly. It's a corner point, so because it's a corner point, there has to be an edge, visible edge over here. So these parts, they have to be visible. And now comes the important part. Till where exactly are we supposed to draw this plane face? That plane face is going to end at the intersection of this tangential line with the circle. So this is the point till where we'll have to take it. So I'll have to draw a projection line here and extend these lines right up to those points. Now this is not going to be visible here, and of course this is just a projection line, and these are the solid edges which will be visible to us. There is one more set of lines that is hidden. Okay, that's visible. There is one set of lines which are visible, which is this one. This is going to be visible. Of course, we'll have to draw one more line here. Okay, and one more set of lines that are hidden. So these edges are going to be hidden because they're going inside the cylinder. So let me make them hidden. So how do I make them hidden? I'll take this and apply here. Okay, So we have drawn the front view. This over here is the front view. This over here is the side view. Now we have to draw the top view, because in the question he has asked front and top view. He's not asking the side view, but side view, of course, we have to draw it. There's no other way. There is no way you can draw this complete diagram without having the side view, and that's the reason why we have drawn the side view. Okay, let's proceed to draw the top view. How to draw the top view? Well, we have to take vertical lines from there, from the intersection point between these reference lines. We'll have to draw a circle, and we'll have to trim this off. So this is the circle we need. So whatever length is coming out here, the same length has got to be coming here on the vertical line. So we are just taking the compass. If you're doing the manual drafting, of course, you have to keep the center point of the needle over here, keep the pencil at this point, and draw the arc. So that will give us now the same lengths, same horizontal lengths are getting transferred over on the vertical lengths. Okay, so now the diagram seems to be coming into shape. So this here what we have drawn is the bottom base, okay. The bottom base actually starts here. Fine. So let's try to break this part, and here this is the base. This now the cylinder is going to be appearing on top of this. Cylinder will be appearing on top of this. So cylinder is going to be appearing on top of this, and we're supposed to draw the cylinder. We'll have to take vertical line from the quadrants, and then we'll have to transfer this distance to the horizontal edge, and then I'll have to draw these lines over here. So this is the outer cylinder. Fine. This is the outer cylinder, and that outer cylinder is starting at this point. So I'll have to draw a projection line up to this point, and I'll have to break this apart. Okay, so this here is the outer boundary of the outer cylinder. Now the hole, of course, is going to be coming inside of it. So I can just take this distance and take offset of this, apply this invisible edges over here. But of course I'll have to draw these edges, take arcs, and continue to do the same procedure for that. Coming to this edge, this is on the base plate. This is on the base plate. So this hidden edge are going to be only up to on the base plate, not on the cylinder. Be careful. These are just projection lines. Okay. Next up, we'll have to draw the ribs. Now till where the ribs have to come, once again the ribs have to enter up to this point. You can see there is a very slight distance between these two, but that distance as well might become very important. Anyway, so let's go ahead and draw these ribs. These come up to here, and this rib crosses this slightly into like that. So this here is the rib. So let me just draw this once again. It's not just touching it exactly, slightly penetrating into it. And the same thing I need to do it on the opposite side of it. Once again, it's going to be penetrating like this. Oh, fine. So it seems my diagram is now complete. The top view is indeed complete. So I've selected the top view, all the important edges you can see here. This is how the top view needs to be drawn. And of course, thank you for being patient and watching this whole video. For many more videos like this in future as well, if JNTU gives me some question paper to solve to make the key, which I know they are going to provide me eventually. The question paper is going to reach me directly or sometimes indirectly, and when I have to solve those problems, I'll make sure that I'll of course make a video on that and make the video available on my channel. So subscribe to my channel. Don't forget to subscribe to my channel if you want all those updates in the future to reach you. Spread the word, of course, to all your friends who might be in need of this. My aim is to make this subject very easy to understand, and I'm trying to make use of CAD technologies to make that enjoyable as well. Thanks for watching once again, and goodbye till the next video.